Okay, welcome to Loving the Physics with Mr. Goldthorpe. And let's start Physics 20. So I'm going to get you guys to turn to your workbooks. Start at Unit 1 here. Feel free to look at the comics at any time. But we're going to jump right in and talk about fundamental skills. So the first few lessons will be just basic skills that we'll need all the way through the course. And you need to be aware that every one of these skills we talk about here, you need to have mastered because they show up in every single unit for the rest of the course. So we need to have them mastered now. And a lot of it will be a review for you. Let's start with the idea of measurement. Like how to make a measurement, for example, with a ruler. Now there's a rule that we actually use for how many digits you're allowed to show. And the key thing you need to keep in mind is you're only allowed to have one uncertain digit in your measurement. One digit you're not quite sure of. Let me illustrate with the diagram below. I'm just going to make it a little bit bigger so you guys can really see this. So again, here's an object we're trying to measure. Now if you take a look at it, you can see that it's very, very clearly bigger than 18. Like it's bigger than 18 for sure. So the 18 would be considered certain. But the next part, if I kind of just do a dotted line, I mean, this one we have to kind of guess. And it looks like kind of like 0.3, but I'm not sure of that. Okay, this one could be a 2, could be a 4. I'm not sure. Whenever you have to make a judgment call like that, like you're not sure of it, we call that the uncertain digit. And that's where you stop. You don't do any more digits after that. You're allowed to have one uncertain digit, and then don't forget the units. And you don't have to keep the question mark there, but that would be considered the proper number of digits for this particular measurement. Good? So that's how many digits we show for a measurement. Good. Next skill. Let's talk about significant digits. Now in that box, you guys can see that we have a very clear kind of description on how to do it. I find it's actually best if I just show you with the numbers below. So underneath, I've got a variety of examples for you guys. Let's walk through each of them. So the key thing here is you actually want to start from the left. So look at A, 28,000 kilograms. We're going to start from the left-hand side. And then we're going to go to the first digit that is not a 0. And you can see that that would be the 2. The 2 is not a 0. So that would be the first significant digit. That digit and every other digit to the right will be significant. So in this case, all of them are significant. So this one would have 5 significant digits. Let's try the next one. So again, you're starting from the left. You go to the first digit that's not a 0. That would be the 7. That digit and every digit to the right would be considered significant. So this one would have 3 significant digits. Good? Now this is what you do for measured quantities. But the ones that are below are kind of tricky. Like when you look at 1 millimeter as 1 times 10 to the negative 3 kilograms, you might be tempted to say it's one significant digit. But see, this is not a measurement. This is a definition. And if it's a definition, it's considered perfect, which means it has an infinite number of sig digs, or as many digits as you need. Similarly, we have 7 tennis balls. Now, when you guys are counting tennis balls, you have to realize those are exact. You either have 1 or 2 or 3, but you can't have anything in between. So this would be considered counting, reasonable numbers of objects. And when you're counting, it's also perfect. It therefore has an infinite number of sig digs. You can only have 1 tennis ball or 2. You can't have 1.2 tennis balls. Good? So those are kind of tricky, the C and the D. But the most important skill is what you guys see up here at the top, how to deal with measurements. Okay, so that's significant digits. finally, let's talk about scientific notation. And it's really important you guys understand that scientific notation has to be a number between 1 and 10 multiplied by a power of 10. Kind of like 6.23 times 10 to the 5th meters per second. See, this would be considered scientific notation. But if you did 0.9 times 10 to the 3, or 16.5 times 10 to the 4, these are not scientific notation because they're not between 1 and 10, the number in the front. Okay, so now we know what it looks like. How do we convert things to scientific notation? All right, well, let's take a look at the first one here, 84,170 seconds, and let's say we know that it has 3 significant digits. So how do we take this one on? All right, so what we do, let's put a decimal place here. Now what you know is we have to put the decimal, basically we have to put the decimal place in such a place where the number will be between 1 and 10. So notice if we put the decimal right there, right after the 8, then that's going to make it 8.4, which is between 1 and 10. And you can see that what we've done is we moved it, and I guess the way people typically show it is kind of like this. We take the decimal place and we go 1, 2, 3, 4. So we're going 4 digits to the left. Now, if I express the number now, we know this is going to become 8.4170. And then we have to do the proper power of 10. Now, you can use a memory system if you want to, but I'm going to show you guys logic. Because we know that that 4 will be the power of 10. Is it going to be 10 to the 4th or 10 to the negative 4? That's really the only choice we have. And here's the rule. You have to realize that this number right here is a big number. In other words, it's greater than 1, if you want to be really specific. But it's a big number. And when it's a big number, do you think that would be a positive or negative exponent? Answer, positive. So there's 10 to the 4th. And then we put our unit. But notice it has to have only 3 significant digits. So let's show 3, 6. So we go to take the first 3 digits. Those are the only digits we're allowed. And the question now is, do we round it up or not? Is it 8.41 or 8.42? And if you take a look at the next number, notice this one is 5 or greater. If it's 5 or greater, you round up. So therefore, our final answer will actually be 8.42 times 10 to the 4th seconds. Good? Okay, now just to be complete, let's try this one over here. And again, you guys are welcome to try this one yourself first, always. But now we need to take that decimal place and we need to move it all the way over to just after the 5. And that's going to be 3, 6, that's 8 to the right. 8 decimal places to the right. Good. So that's going to leave us with 5.61 times 10 to the power of, now it's either going to be 8 or negative 8. But can you guys see that this number here is a small number? It is, you know, if you want to get really, I'll just put it this way. It is less than 1 in magnitude. And because it's a small number, would that be a positive or negative exponent? And that'd be negative. So this becomes negative 8, and then again, don't forget the units. But we're told it only has 2 significant digits. So we can only take the first 2 digits. Notice that the next digit here is less than 5. And if it's less than 5, that means you don't round up. Try to make that up look a little bit clearer. So don't round up. Therefore, our final answer will be 5.6 times 10 to the negative 8 meters. Done. Good? Okay, so now you can actually take on the first few homework questions, and I'll see you in the next lesson.